The Earth is made up by 7 planets. Earthquakes are geological phenomena resulting from the movements of the Earth's tectonic plates. These immense plates interacted their boundaries, stress accumulated along fault lines. The release of the energy is what caused an earthquake. The 2010 Chinese earthquake, known as one of the greatest earthquakes, striking on February 27, 2010, near Concepcion, it had a magnitude of 8.8. The quake claimed 525 lives and triggered a catastrophic tsunami, causing additional casualties and economic havoc. It also significantly altered the regional's landfall. We don't want to go through other disasters like this. That's why engineers need reduced earthquake damage. But how can we protect our buildings from earthquakes? The answer is a stranger structure, because the natural stiffness of a structure is closely related to its geometrical configuration, and we all know that triangle is the most stable shape. Therefore, adding one or several bases to a square structure can effectively transform it into a triangle configuration that enhances the structure's natural stiffness. This is what called triangle basing structure. Also, a seismic-resistant structures typically require robust and thin non-linear wall to provide vertical support and stability. Meanwhile, lightweight and thin beams help reduce overall weight and short horizontal loads. This design effectively disperses and absorbs energy during earthquakes or other external impacts, ensuring structure's stability and safety. Our group have followed this design and got a good result in the workshop. But earthquakes always followed by a series of disasters, and the landslide is one of the disasters. In order to understand landslide, we need first to know the origin behind. The friction angle is a parameter that describes the physical property of soil or rock in resistant relevant surface sliding. It is a fundamental concept in understanding landslide and liquefaction phenomena. Earthquake can trigger landslide by increasing the shear stress on slopes, reducing the friction angle, making the material more prone to movement. Similarly, in liquefaction, seismic shaking can increase the pore water pressure in loose, saturating soils, lowering the effective stress and friction angle, and finally turns solid soil into liquid-like substance. To better understand the relationship between landslide and force acting on the soil, our group has simulated a landslide and collected the data, and we end up with a graph like this. This graph can show us how does the angle of slope changing in the earthquakes. All in all, please keep engineers' responsibility in mind. Remember, it is not the earthquake or building kills people, but the stupid mistakes made by engineers.